Is going to cover the behavior of the grazing animals that we see on rangeland. And one reason that I wanted to make sure that you guys got a little bit of education behind animal behavior is because it can really help predict the production of rangeland and the health from an ecological standpoint. All right, so when it comes to animal behavior, there are several effects that we have to take into consideration about how animals behave. So the first one is we know that behavior can be a genetically inherited trait. And so those abilities are actually coded for by genes encoded in the DNA. Therefore, they can be inherited or passed from one generation to the next. So, things that we know about animal behavior traits that are coded for or are inherited include physical characteristics, sensory characteristics, and then physiological abilities. So, physiological would be things like digestive system dictating behavior traits. The second aspect of animal behavior is what we call um, innate experiences. So these are going to be instincts. So traits that or measurements that are not necessarily related back to a genetic component, but instinctual. And the third component is the learned behavior. So what animals learn through the course of their life. So just like babies, they know very, very little when they're born, but they learn over time the different ways to behave. Um, so, or some of them do. Some of them still don't have a clue. But these are the big components that make up animal behavior. So, again, what is inherited, what is instinctual, and then what is learned. So, when we think about the physical abilities related to what an animal can eat, that really relates back to the animal's ability to digest cellulose, and that is going to be dependent on digestive system. So whether we have a monogastric or a ruminant animal, and how complex that system actually is. So other physical traits that dictate what an animal will eat and will actually dictate their behavior is what their prehension capabilities look like. So, how do they capture their prey or their food, and how they consume their prey or their food. So, again, our carnivores are going to have really sharp teeth associated with their jawline. Omnivores are going to have a combination of sharp teeth and flat molars, and herbivores are going to have um, a few teeth in front that are very, very sharp to clip the grass, and molars behind to help grind up the material. So, all of those things are really going to be associated with the physiology of an animal, and most of those traits are actually coded for by DNA, therefore, they can be inherited from one generation to the next. When we think about using animal behavior to manage rangeland, it's really important that we take into consideration what their diet actually consists of. So, our concentrate feeders are going to be ruminant animals that are going to focus more on eating matter that concentrates a lot of nutrition. So, this would be like berries, browse, all of those good things that have a higher level of nutrition. So, the intermediate feeders, these are going to be like sheep and our wild sheep species as well. And these individuals are going to eat a pretty balanced ration given the choice of grass, forbs, and browse. So they actually have an affinity for each one of those plant types. And then our roughage feeders are going to focus mostly on consuming grass. They make very poor browsers. However, observational data tells us that you can actually train animals to survive on browse. Um, However, they will prefer grass species over browse in the long run. So, as you are designing management plans, it's really important that you know what rangeland you're actually going to be placing animals onto and inventory the plant species. So, what percentage of shrubs are there available and what percentage of grasses and forbs there are available, because that can really dictate what type of animal goes to a certain piece of rangeland. So, as we look more closely at those abilities or those traits that are inherited from mom and dad, those can really affect where animals eat in terms of plant types that are available. So, this graph here actually shows four different species. So, cattle are going to be in the solid line, horses are the long dashed line, deer are the dotted line, and bighorn sheep are going to be the dotted and long dashed line combination. And so what we have here on the x-axis is the percent slope, and on the y-axis is the percent of observations of what the animal is eating. So in this study, we actually found that cattle don't use a lot of varied slope. So if you get up over about 21-22% slope, cattle are not going to use that land. However, anywhere between 0 and about 20% slope, cattle will actually use quite a bit of. Our horses are going to use up to about 10% or 8 to 10% slope pretty commonly. However, as slope starts to increase from 10 to 20 and even upwards to 45%, horses are going to stop using that area after you get a slope that is greater than 45%. But they will use more slope than our ruminant or than cattle for sure. Deer are similar to horses, and this is actually surprising because they have two different digestive systems. So our horses are monogastric, they tend to be cecum fermenters, and our deer are going to be ruminant animals. So even though there is two different digestive systems present, the ability to utilize different or the same slope is actually the same, which is interesting. And then bighorn sheep are known to get out and utilize a lot of different sloped areas. So you can see that the percentage of observations of bighorn sheep actually grazing areas that are less than 10% slope and 45 to up to 80% slope are about the same, which is really interesting. So bighorn sheep are going to go where there's more nutrition. And a lot of times that is actually in areas that are over 45% slope. All right, so one thing that we can take into consideration from a management standpoint is the breed type that we utilize on rangelands if we have that ability. So if we're looking specifically at cattle species, we can actually utilize the breed characteristics associated with different breeds to better manage rangeland. So, for example, here on the left-hand side, we've got a set of Hereford or a couple of collared Hereford cows, and all the little purple dots here are the percent that are the GPS coordinates of where they grazed over a 3-month period, and we can see that those GPS coordinates are actually concentrated in the lower elevation and lower slope percentage areas. On the other hand, though, on the right-hand side, this is the GPS coordinates for Tarentaise cattle that were collared for the same 3-month period, and we can see those cattle actually utilized a higher percentage slope area than the Herefords did. So these animals were collared at the exact same time in the exact same pasture, and they were actually commingled for the same amount of time. So we can actually really truly see breed differences here. And a lot of that really goes back to the evolution of these breeds. So Hereford cattle originated from England, where there's not a lot of topography, and the Tarentaise cattle actually originated out of the Swiss and the French Alps. So they were developed in really high slope, steep country. So it makes sense that their genes actually were inherited over time to deal with those conditions, compared to the Hereford cows, which are going to use a smaller, lower slope type area. All right, and this is some research that I've been involved with for about the last 10 years. And you guys already know the answer to this question, but I like to pose it anyway. Based on physical appraisal, which one of these heifers, 7710 or 7913, would you actually pick to graze rougher terrain or a terrain with a higher percentage slope? And so this was part of a long-term research project, which is still ongoing. We collared both heifers and for a 3-month period as well. And you can see that one heifer used this low kind of canyon valley area that doesn't have a lot of slope associated with it. And one cow actually got out and traveled and climbed to the top of these mesas. And so she utilized a higher percentage slope. And both of these cows, if we look at them, they're both the same breed type. They're both black baldies, which is a combination of Angus and Hereford genetics, both British Boss Taurus breed bases, but in crossbred individuals. So what this shows us is that not only can we use breed differences to actually better manage rangeland and utilize or increase grazing distribution on a piece of rangeland, but there's also animal-to-animal variations just depending on learned ability and that animal's willingness to actually utilize different percentages of slope. So you can see here that 7913 actually used a higher percentage of slope on a more consistent basis. She's the green line. And 7710 used a high percentage slope for the first 3 weeks and then found the bottom ground and stayed there for about 5 weeks before actually being forced to move up to higher sloped areas. So the answer here is that 7913 actually was the heifer that utilized greater slope areas, and she's a little more fluffy and has a greater body condition score than heifer 7710. So again, just getting back to some of the genetic components that can be associated with grazing behavior, we can actually utilize breed as well as individual variation with these animals to better utilize rangeland and increase the grazing distribution associated with each individual piece of rangeland. So in this example here, we also did a little bit of research in my lab at New Mexico State where we looked at Brangus animals and their travel patterns. So what we ended up finding was that we took Angus animals and tracked them and over a 3-month period, and we also collared Hereford animals at the same time. They were on the same ranch, and what we ended up finding was that Brangus ended up traveling further from water than the Hereford or the Angus individuals. So we had 3 different breed groups collared here. We had Brangus individuals, we had Angus individuals, and Hereford individuals collared. And they were all in the same pastures. They were all ran together for the same amount of time. And based on the diet and the GPS coordinates, we saw that Brangus animals traveled further from water than Hereford or Angus. In addition to that, the Brangus animals also consumed a way different diet than Hereford or Angus, so their selectivity is much, much different. All right, so we're going to pick up with inherited behaviors in the next segment.